Okay, hello everybody. So what if you've never used the Cocalc before? So this is a little tutorial. I'll type cocalc.com, and then you can see sort of what it looks like. This is a Jupyter notebook, and you can make plots and all sorts of things, and it's free to create an account. So I already created an account. I created a project. 2021 Lawrence, I called it that. And I created some folders, so you can see I have a folder for our class. And in fact, if I clicked on this file, I like to keep, when you'd see the solution to, I chose the first variety. But what to do to make a new file is you can press that, or here, I like to choose a Sage worksheet. You could also choose a Jupyter notebook. So I'll show you Sage worksheet because that's the one I like to use. So it suggests a name. I usually keep the date and I name it something like demo how to use Cocalc. And then I press create, or I press enter. So here we go. This is a Sage worksheet. So I'm using Sage. And first of all, just to get an idea of what's going on, there's all these options. So for example, if I click calculus and I choose one of these, like numerical integral, then it gives me an example. I didn't type any of this. It just gave me this example. And I can hold shift and enter, and it evaluates the cell, and it'll put the output down here. When it's done computing, the green will turn blue, and it gives me the answer. So this is apparently the integral of this function from 0 to 3. Okay, I can look at some other things. I can differentiate. Okay, differentiate this function with respect to x. I press shift, enter, and it gives me the answer. So I can see all sorts of things like plotting points. Okay, so I guess I take points, and here's some points. And the color is dark green, point size is 50, aspect ratio 1, and then there's this show command. Well, anyway, I don't have to understand it. I just press shift, enter. Oh, and there's some points. And now you can mess with it. Like, what if I make the points three-dimensional? Will that work? I don't know. I'm just typing comma and then putting another dimension. Oh, interesting. It seems to have worked. It's not great because I didn't do a good job of choosing where the points are. Maybe if I made them a little lower. Yeah, that looks a little bit nicer. I wonder if I could say frame equals false. Ah, now I have my points. And I can move them. I'm clicking and then moving my mouse, and I can look around at them. Okay, so that's interesting. I can get rid of this stuff. So I'm just going to get rid of it all. To define a function, you can just type f of t1, t2 equals t1 times 4 plus t1 times t2. And now I have this function, so I can call it and get an output. Another way, so that's the definition of one line, but if I want a longer function, I say def t1, t2 colon. And now I can really like put some things together. Plus t2 squared. So that's my denominator, and I'm going to use it in my formula, and I'm going to say return. Now these are square brackets. It's sort of like a list. And I'm going to say 2 times t1 divided by the denominator, and then 1 minus, or maybe 2 times t2 divided by the denominator, and then 1 minus t1 squared minus t2 squared divided by the denominator. And so now I have this function f, and I can call it on a point, and it's going to give me sort of a point in 3D, I guess. And so now I can plot them. So like, first of all, what if I type this? It gives me a random number. What if I type 2? No, it doesn't. So if I don't know how to call random, I press tab, and I wait, and then it'll tell me what I can do. Okay, it gets the next random number in the range. Okay, I guess that's all I can do. Oh, but that gives it an example. Sample equals, and it makes an open bracket, random for I in 1 to 4. And it prints out the sample, and I see that it generated 4 random numbers. So this right here is really a useful syntax. It generates a list. Yeah, it's sort of like set notation, actually. And so maybe I'll show that. So let's create a sample. And let's say we're going to create a list for blank in 1 to n. So I'm going to create a sample of n equals 5 points. So I just didn't want to give the indexer a name. I could say for I in 1 to n, for j in 1 to n, for nothing in 1 to n, because I'm actually not even going to use that indexer. I'm just going to create a random number. So let's look at what the sample is. I'll print out the sample. You see it produced 5 random numbers between 0 and 1. Okay, so why don't I do that for, let's see, instead of just producing a random number, I'm going to say f of a random number, comma, a random number. So now I'm evaluating my f at 2 random numbers and doing that 5 times. And so you see I get now my sample is a list of lists, and each of them is 3 points. So this is a way to generate points on the sphere using a parameterization of the sphere, namely f. So let's do that. Maybe I want to generate 200 points on the sphere. Okay, that's too long of a list to print out, so let's not print it out. So now I just have sample, and I can say, what's the length of sample? Okay, length is not defined, but instead length of sample is 200, right? Because I generated 200. I did it 200 times. I could have called this I. It would have been the same. The length is 200. I can take the first item. I can take the second item. But actually, Python is 0 index, so really 0 is the first item. And the second item is index 1, and index 2 is the third item, etc. And so they're stored in this list called sample. Sample is a list. It's very long. So then I can plot. So for sample in, let's call it samples. Let's call it samples. And then the length of samples is 200. And now for sample in samples, colon, this is a for list. PLT equals plus equals plot of a 0.3D sample. I'm first going to create an empty plot and then add a bunch of points to it. And I think this should work. Let's just try. I'm going to press Shift Enter. Okay, so now what's PLT? PLT looks like this. Interesting. So these are my random points. I only plugged in values between 0 and 1, which is why I'm not getting the whole sphere. Let's try it with 2, or let's try it with 1,000 points. Now my length of samples is 1,000. Plot all those points and look at it. Interesting. Okay. So yeah, this is how you generate points on a 2-dimensional object and then look at them. Now, your problem is to generate points on a 3-dimensional, or a 2-dimensional object in 4-dimensional space. Then you have to figure out how to look at them. And that's first a mathematical problem. Then when you know what to do mathematically, then it's a programming problem to get the computer to actually do that. And if I want to search how did I know how to do this? Well, I type Sagemath plot. And then the first item, or really the first few items, are all going to be, here's a tutorial for advanced 2D plotting. Here's plotting tutorial, so I can click that. And this will show me all sorts of things to do, and I can search through here to try to see if it has the word points. And I guess it occurs 3 times. Let's see, where is it? Well, interesting. You can do a parametric plot. So I'm just discovering all sorts of things on Sage. And yeah, I guess this is 3-dimensional plots. Plot 3D. So maybe I don't like this tutorial, so I go back here and maybe I say 2D plotting. Ah, this looks good. Look at, here's a point. I wonder, next topic, text in plots, previous topic. So I'm gonna just click this manual 2D graphics. How do I get like a 3D graphics? Well, I guess I could search 3D graphics. Okay, that didn't work. So let's do 3D plot Sagemath. And oh, here, maybe this is it. Here we go. That's what I was trying to find. And now list plots, implicit plots, plotting 3D fields, parametric plots, basic plot options, introduction. So I click introduction. Plot 3D, list plot 3D. A three-dimensional plot of a surface defined by a list of points in three-dimensional space. Oh, that looks pretty useful. Oh, point. A position in 3D represented by a sphere of fixed size. Let's click that. So then I can see more about how to make points. I need to give it a center and a size. And here's an example. So I can always just copy this example. Copy. Go back to my notebook. And then I can see what it does. I paste and I press Shift-Enter. And so now I see that it's created this little thing, which is a point. Right? And so that's actually what I was doing up here many, many times. Point 3D, and then you need to give it a list. And you can give some optional like arguments, extra arguments to this function. I didn't give them, so I guess the default is to have it blue and a certain size, and opacity is a certain thing by default. So I can just get rid of these down here and just say that, and then we'd see that now it looks more like what I was getting up here. So interesting. And if I want, I can then say, okay, well, what else do I know about this plot 3D function? So I put my cursor, not over here, but in the parentheses, and I press Tab. And now I get all sorts of suggestions for what to do, and I get many, many examples. And so I can figure out how to do all sorts of things, like plot hypercube vertices and all sorts of stuff. A point or a list of points, the size, yeah. Okay. So I guess I didn't have to do a for loop over each point in my samples. I could have just given it the whole list. So let's try that. Point 3D samples. This is the entire list. And boom, it already did it. So that was way easier. I made it harder because I don't memorize how to do these things. I end up memorizing some, but really I just try and it'll usually fail, and then I search Sagemath plot 3D and I find something to help me. Yeah, so the big things are defining functions. You know what functions are, they're maps. Using this def, name of function, list of arguments, colon. You can take your time and define like a bunch of helper things along the way. Take your time in writing the function before finally returning some value, right? And then you can call the function and it returns what you told it to return. Okay, and this is sort of interesting. Yeah, pretty fun. Okay, that's how, at least how I would get started. Big part of this is learning how to just Google Sagemath something. What do I need to do? How about Sagemath QR decomposition? Then I get sort of, well, here, a whole tutorial by somebody at Brown, okay, or a quick reference for linear algebra. This looks great. I'll click that. Wow, this is going to be helpful, because we need vectors. And so now a dot product, inner product, norm. Oh, Graham-Schmidt, that's great. But down here, it's going to be maybe very helpful is the QR decomposition. If you're, well, there's just one possible solution to how to plot a four-dimensional thing is to project it to three-dimensional space. And to do that projection, you could use the QR decomposition. from linear algebra. But either way, this is a great, this looks like a good way to learn some Sage. Okay. So excellent. Now here's how to plot some points.